Hello again. Okay, so we have hopefully at this point played around with some basic trig identities and their Pythagorean identities. Okay, and now we're going to look at some different ones. Keep in mind this is section 14.6 in your textbook. We're going to look at the negative angles, the cofunctions, and the sum and differences, not necessarily in those orders. Okay, so take a look at what we have so far. The negative angles. Yeah, they're written out for you. Okay, so we have the negative sine angle, and it states that if you have sine of a negative angle, right, so that would be our horizontal reflection, it's going to be a negative sine of theta. Well, think about what sine is, yeah? Think about if I'm here, okay, if I rotate to a positive, positive theta, and theta is just our angle measurement. Okay, and up here in the first quadrant, sine is positive. Well, then if I rotate to its negative theta, sine down here is negative. If I rotate over here to a positive theta, and then I rotate to its because here, sine is positive, right? And then I rotate to the negative theta, this is going to be a negative sine. It's basically just talking about the relationship between where sine is positive and negative on the coordinate plane. And then if we look at cosine, okay, we say that the cosine of a negative angle is going to equal the cosine of a positive. Well, let's check it out. Okay, if I rotate into the first quadrant with a positive cosine, or with a positive angle, sorry, so theta, cosine is positive. If we were to look at its negative theta, what is cosine? Cosine is positive. So it's looking at the relationships, and then tangent follows suit. Tangent is sine over cosine, so it makes sense that it would follow from there. Okay, so negative angle identities. Sine of a negative theta can be written as a negative sine theta. Cosine of a negative theta can be written as a positive cosine theta. And then tangent of negative theta can equal a negative tan theta. Why do we need these identities? For proofs and for solving in the future. Okay, so angle, sum, and differences. What color am I on? Blue. Okay, so we have a couple angles that I want you guys to sort of identify here. Now keep in mind we're looking at a unit circle. Okay, so our first angle is this big angle right here, and that's alpha. Okay, alpha is just, I'll leave it like that. Alpha is just an angle measure. Okay, alpha, beta, theta, x. And then we have this little angle right here, and we're going to call that beta. And if I take alpha, which is the bigger angle, and I subtract beta, I'm left with this measurement, which is just that, alpha minus beta, which makes sense. You have the bigger angle of alpha, and you subtract the smaller angle away from it. What are you left with? The difference, right? Okay, well, look at the coordinates. If I'm, what color am I? Sorry. If I'm here, okay, for alpha, we know on the unit circle that this is going to be cosine alpha, sine alpha. Because on the unit circle, x and y, right? We go over x units, up y units, which coordinated to our cosine and our sine. Okay, so then for beta, which is the smaller one right here, this point is going to be cosine of beta, sine of beta. But what if I wanted to know the distance between these points for alpha minus beta? How would we figure that out? Well, there's a couple ways for us to do that. And the first would be the distance formula. Now remember back in the day, your distance formula is the square root of the difference of your x values squared plus the difference of your y values squared, right? Well, we could also write that as d squared to get rid of that radical so it looks a little bit cleaner. And then it equals those differences squared and then summed together. Okay, so if we were to apply that to this point and this point, because we want to know what's the distance between that, we would say that d squared is equal to, well, let's say that alpha is our x sub 2, right? So then we would have cosine alpha minus cosine beta quantity squared plus sine alpha, because we're going to stay consistent, minus sine beta quantity squared. Well, multiply it out with me. I know it's going to look a little funky, but we can do this. So then we get cosine squared of alpha minus 2 cosine alpha cosine beta plus, oh, whoopsies, plus cosine squared beta. That's the first parentheses squared. And then we get plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. Okay, rad. Noticing a couple things. I'm noticing that cosine squared alpha plus sine squared alpha, well, that's going to give me 1. And then we've also got cosine squared beta and sine squared beta, because our Pythagorean identity, it says it's 1 if the angles are the same. So I'm going to say that it's 1 from the alphas plus 1 from the betas. And then we have minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. And then we'll just simplify. So d squared is going to equal to minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Okay, so that's one way for us to figure out what the distance is between those 2 points. Okay, well, there's also another way, and that would be, because if I know 2 sides in an angle, that would be the law of cosines. I know you're thinking, what? We don't have that much information. Yes, we do. We know that this is the angle, right? Because we're trying to find this distance. We know that this and that leg of the triangle is 1. Okay, and this is the angle, right? So that's the side we're trying to find. So that would be our d. What's this distance? So then we would say, law of cosines, for those that hopefully learned it, maybe. Law of cosines states that, let's say we're trying to find, we'll call this angle C, right? So little c squared is equal to little a squared plus little b squared minus 2ab cosine of big C. We'll fill in what we know. Little c is going to be our d squared. Little a is 1. Little b is 1 because we're on the unit circle. Minus 2 times 1 times 1 times the cosine of alpha minus beta, because that's the angle. You with me still? I hope so. Okay, so then d squared is going to be equal to 2 minus 2 cosine alpha minus beta. Okay, so different ways of finding the distance, but they're exactly the same. Now, would you agree with me? Give me my orange. Would you agree with me that if d squared equals that and d squared equals that, there are 2 different ways of finding the exact same thing, that I can set them equal to each other? I hope you're agreeing, because you absolutely can. So we're going to say 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta is equal to, okay, that's the first, that's this guy, equal to the second one, 2 minus 2 cosine of the quantity alpha minus beta. And you might be thinking, why would I want to do that? Because it's amazing. Okay, so we're going to subtract the 2's. So we get negative 2 cosine alpha cosine beta minus 2 sine alpha sine beta equal to negative 2 cosine alpha minus beta. Okay. I like where this is going. I'm going to divide everything by a negative 2. So then I end up with the cosine of alpha minus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And ladies and gentlemen, I would like to introduce you to, I know that was a lot, but holy heck, that was awesome. I would like to introduce you to, as soon as I can find my highlighter, the cosine difference formula. Wow, the crowd goes, wow, that was so awesome. Ah, okay, now, no, we're definitely not going to do that for all of them. I think it is well worth seeing where it comes from. It's super cool. But let me just write them out for you, okay? So go down, if you will, with me. All right, I want to go back to my pen. That's what I want, and I want blue. Okay, so we're going to go down here for the sum and difference angle formulas, okay? Where did it come from? It came from where we just showed you, which was amazing. So if I have the sign of alpha plus or minus beta, so alpha and beta are the two angles, it's going to look like this. Sine of the first, cosine of the second, plus and minus, cosine of the first, sine of the second. Cosine, and I'll explain the plus minus relationships in just a second. Cosine of alpha plus and minus beta is going to equal, you guys just saw it, cosine alpha, cosine beta, minus plus sine alpha, sine beta. Okay, here's where it matters. Really pay attention. Sine is the same. So if I'm adding the angles, I add the identity or the formula. If I subtract the angles, I subtract the formula. Sine, same. Cosine changes. So if I'm adding the angles, I subtract. If I'm subtracting the angles, I add. Okay, really important that you guys understand that. And then the last one is tangent. Now remember, tan is sine over cosine. So the signs will be the same in the numerator. They will change in the denominator. Same over change. And it is the tangent of the first angle plus and minus. Tangent of the second angle over 1 minus plus tan alpha, tan beta. Okay? So yes, sine over cosine. Sine, same. Cosine, change. Okay, so the last one that we're going to see are the cofunctions. Co means more than one, right? Function. Well, hopefully you know. I'm going to just show one of them. They're pretty rad. So if we have the sine of pi over 2 minus theta, right? Think of pi over 2 as your alpha and theta as your beta. Okay, so we're going to use the sum and difference formulas. So that means sine of the first angle times the cosine of the second. Sine is the same. Okay, so then it's going to be cosine of the first angle, sine of the second. Okay, well, the sine of pi over 2 is 1. So 1 times cosine of theta minus cosine of pi over 2 is 0. So then we're left with cosine of theta. That's why they are true. You can do the other two. It's pretty awesome. I want to get through some of these examples with you. All right. So find the exact value. Ladies and gentlemen, when it says exact value, if you grab your calculator right away, you are wrong because that is not exact. That is approximated. So we need to think to ourselves, man, okay, what can add or subtract to 105? And right away, I'm thinking 60 plus 45. It is possible you might pick a different angle measure. That is okay. But I'm going to use the sum formula to say that this is the same as the sine of 60 plus 45 degrees. Why not? So then I'm going to write it out. And plus, you want to use the angles in case I think I forgot to mention this, that we're familiar with. Okay, 30, 60, 45. Please, 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 30, 60, 45. Okay, so then we've got the sine of 60. Cosine of 45, sine is the same, so plus. So sorry. Cosine of 60, sine of 45. Nice. Okay, so sine of 60, if you think about your unit circle, right? Cosine, sine of 60 degrees is going to be rad 3 over 2. Cosine of 45 is rad 2 over 2. Cosine of 60 is 1/2 times rad 2 over 2 for the sine of 45. That leaves us with the square root of 6 over 4 plus the square root of 2 over 4, and they do have common denominators, so we can combine them. Square root of 6 plus the square root of 2 all over 4. Okay, so the next one says cosine of 255. Well, obviously that's not going to be 30, 60, or 45, but I do know that I can do 210. So we'll do the cosine of 210 plus 45. 210 has a reference angle of 30, and even though it's in the third quadrant, it's still usable because we know that it has that reference angle of 30. So cosine is going to be the cosine of 210 degrees, cosine of 40. Cosine changes, so minus the sine of 210 degrees times the sine of 45. Okay, so we know cosine in the third quadrant is going to be negative. It's a 30-degree reference angle, so it's going to be negative rad 3 over 2. Cosine of 45 is rad 2 over 2 minus sine in the third quadrant is also negative, so it's going to be negative 1/2 for a 30-degree reference angle in the third quadrant times rad 2 over 2 for the sine of 45. So then we get negative square root of 6 over 4 plus rad 2 over 4, and it's plus because of subtracting a negative, so then we're left with negative rad 6 minus rad 2 plus rad 2 all over 4. And that is the exact value of the cosine of 255. For the exact values, you cannot use your calculator because it says exact. Okay, I think I've gotten my point across. Okay, verify. Let's do it. So then cosine of 90 degrees minus theta. This is alpha, this is beta. I'm going to use the sum and difference formula. And I'm going to use the left side. Remember, when you're verifying, you want to use the side that has more to work with. So I'm going to say that the cosine of 90 times the cosine of theta, cosine changes, so it's plus the sine of 90 and the sine of theta. Cosine of 90 degrees is 0, so 0 times cosine of theta plus sine of 90 is 1 times the sine of theta. Right away I can see, dun, 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 that we have proved it. Nicely done. Okay, for B, it's the cosine sum formula that I'm going to use, alpha, beta. So we get the cosine of 180, cosine theta. Cosine changes, so it's subtraction, sine of 180, sine of theta. Okay, well the cosine of 180 is negative 1, so we have negative 1 times the cosine of theta minus 0 times the sine of theta. Negative cosine theta is equal to negative cosine theta. Make sure you do not skip steps and make sure that you write everything out in its entirety. All right, last but not least, the sine difference formula. That's going to be the sine of theta. And again, the reason I'm using that, you guys, is because negative cosine theta, there's not a whole heck of a lot that I can do with that. Truly, there isn't. So we can at least use the sum and difference formulas to verify these identities. Let's do it. Why not? Make your life easier. Okay, so sine theta, cosine pi over 2, sine stays the same, so minus cosine theta sine pi over 2. Okay, well, sine theta, cosine of pi over 2 is 0, so that's times 0, minus cosine theta times 1, sine of pi over 2 is 1. This cancels out for sine, so we get negative cosine of theta is equal to negative cosine theta, and you're done. Nice. All right, last but certainly not least, this one's super fun because you get to work backwards. See how well you know those sum and difference formulas, eh? Canada, eh? Sorry if you're from Canada. I went to Canada once, and it was awesome because it was there for a week, and the very last day, somebody said, eh. His name was Jaron. He was super cool. We hung out with him, my girlfriend and I. It was fun. Okay, probably too much information. Anyway, he was cool, and we had a good time. It says find the value. Well, right away, I know I don't know what the cosine of 50, cosine of 40, sine of 50, or sine of 40 is. Have absolutely no idea. And I know that it says find the value. Patterson probably doesn't want me to use my calculator, and you're correct. So I'm thinking cosine, cosine. This part, that's going to be the cosine formula. And cosine changes. So this is going to be the cosine of 50 plus 40, which means I'm truly looking for the cosine of 90 degrees, which we know to be 0. So we're done. Easy peasy. All right, get to the homework.